Welcome back to my factoring phases. And so on phase 7 we're gonna take it's actually not new material. It's going to be a mixed practice. So I'm going to give you guys 6 examples that were like the previous 6 phases that you guys watched, and then I'm going to give you 8 practice problems for you guys to do. Please watch the previous phases if you have not done so. I'm just going to get started so that for those who have been tuning in with this series, then I'm just gonna here we go, let's just do it. First example. Okay, all the instructions are going to be factoring. Please factor this. The first question always to ask yourself is, can I factor something out? Is there a GCF? Is there a greatest common factor? Can I divide by 5, extract a 5 on all of them? No. Can I extract an X on all of them? No. And so we're going to have to do the technique that I have taught you guys on phase 5, where we have to create a 19x somehow, and then we need to break up these terms over here. The only way to break up 5x squared is 5x and x. This is a prime number. For 12 we have 4 times 3 and then 6 times 2. Just for I guess video purposes, I'll just give you the correct pairing. Okay, the 5 will go with the 3 and then the x will go with the 4. Let's try that one out. 5x times 3 plus x times 4. This is 15x plus 4x, and that is the 19x that we want. Okay, first pair that works goes on the outside. Okay, and then second pair that works goes on the inside. Okay. I'm not going to do it over here, but to check your work, you're going to either use FOIL or box method. It's been previously done in the other phases, so if you want to check those out, please do so. But right now, I'm just strictly going to go on factoring purposes, just so that you guys have practice for this one. Okay, so here's a couple, here's an example that you might find on the practice problems. Let's do example number 2 now. Okay, first question always is, can I take out a greatest common factor? And the answer is yes. We can actually extract a 5 on all of these 3 terms, and let's go figure out the leftovers first. 5 divided by 5 is 1, and then after that 15 divided by 5 is 3, so we have 3x, minus 350 divided by 5. Well, 35 divided by 5 is 7. We're going to put the 0 there. Okay, remember that you need to rewrite that 5 back, because you're not eliminating it, you're just really extracting it from the original trinomial. Okay, here is a 1. So now it looks like phase 2 and phase 3 of my series. If there's a 1x squared, don't worry about this first term over here. Now we just got to deal with the last term. What 2 numbers multiplied to negative 70? I can think of 10 times negative 7 or negative 10 times 7. Okay, remember, for negative, 1 has to be positive, 1 has to be negative. But which one adds up to 3? It's going to be this one right over here. Okay, so then at the end, your factors are going to be x plus 10 and then x minus 7. Okay. Alright, here is example number 3. And let me just move this up a little bit. I'll move it all the way up. Okay, GCF, is there a GCF? No. And so we're going to have to do the techniques that I taught you guys in phases 5 and 6. 8k squared and then negative 27. 8k squared, we have 8k and k, but then we also have 2k and 4k as well. And so that was in the previous phase, where this is not a prime number. There might be more than one way to break up that first term. Okay, negative 27. 1 is positive and 1 is negative, because it's a negative number. Okay, we also have negative 9 and positive 3. Again, this is just going to be trial and error basis for you guys. Just to make it a little bit faster, I'll tell you guys which ones to pair up with which. Okay, the 4k goes with the 9. plus the 2k goes with a negative 3. Let's see why. This is going to be 36k plus negative 6k. This is in fact 30k that we want. Okay. Now that we got the correct pairings, let's start putting them in the correct factors. Remember, the first pair that works, and I've proven to you why it worked, because when we did the FOIL and box method, it worked out perfectly. We got back the original problem. So just make sure the first pair goes on the outside and the second pair goes on the inside. Okay. Alright, I'm going to keep going. We are halfway there, and then I want you guys to do some problems. There is a 1 in front of the x squared, so we don't have to deal with that too much. What two numbers multiply to 9? 3 and 3. Do they already add to 6? Yes, does. And so we're going to go x plus 3 times x plus 3. But remember, in phase 3, if you see two of the same factors, we can just write this as x plus 3 quantity squared. Okay, and so this was called perfect square. This was taught in phase 3, so if you want to check that one out, you can go back to that. Alright, let's move on to example number 5. 2 more examples to go, and then I want you guys to do some work. Is there a GCF? Yeah, we can extract a 4. Okay. I'm not even just saying the original problem. 4p squared minus 36. Okay, there you go. Alright, well, 4 divided by 4 is 1. I'm just going to write it as a p squared minus 9. And then we got to bring that 4 over here. This was also in phase 3. And I'm going to show you guys 2 ways to do it. One way is you could, and let me just move this paper over here. You could add a 0p here. Okay, 4 p squared plus 0p, because there's no middle term here, and then minus 9. Then from there you can go and factor. What two numbers multiply to negative 9? There's a 1 over here, so we're not too worried about that. 3 and negative 3. It's a negative because one has to be positive, one has to be negative. This already adds up to 0. So then your final answer is going to be 4 p plus 3 p minus 3. Another way to think about this is a structure of differences of squares. Okay, can we square root the first term inside the parentheses, inside that factor? The answer is yes. Square root of p squared is p. Ignore the negative. Square root of 9 is 3. And there is a minus sign. So the structure again for this is going to be x plus y, x minus y. So just follow that structure for that. Okay. And where are you getting your x's and y's? You're getting it from these over here. Okay. Sorry, I did not put room on those. It's okay. So it's going to be p plus 3, p minus 3. And don't forget the 4 that we extracted from earlier in this problem. So you see that no matter which method you choose, it's really up to you which method. You're still going to come out to the same answer here. So that's example number 5. I know that was a little bit long, but I know students do it differently depending. Anyway, here is example number 6. Last one for me, and then I want you guys to do some problems. Let's see if we can extract, is there a GCF? Yes, there is. 7. Okay, so 21n cubed minus 14n squared. I think I'm just going really fast at this. It's nighttime right now. I'm filming this at 6:50 p.m. and I'm still at school. Anyway, that's not your problem. Okay, 21 divided by 7 is going to be 3. We still have n cubed minus 14 divided by 7 is 2n squared. And remember, we extracted a 7, so that needs to be out over there. Not only we have to think of numbers, let's also think of the variables as well. There's 3 n's here, and there's 2 n's multiplied together over here. What is the maximum n's that we can extract? It's going to be n squared. because there's two n's here, and there's at least two n's multiplied together over here. Alright, with that said, let's find the leftovers. If we're going to extract two n's from this first term, we only have one n left over. And if we're going to extract n squared on the second term, then there's no more n's. Okay? Then that means on the left side, we still have that 7, and then that n squared is extracted. Okay, this was in phase 1. Okay, when we worked with the binomials. Okay, well, I want you guys to now, pause the video. Okay, I want you guys to grab a piece of paper and actually do these 8 specific examples, and you guys are going to factor from numbers 1 through 8. You can look back at the previous examples, the previous phases, to see how to do it again. But in about 10 to 15 seconds, I'm going to give you guys the quick answers, and then if you need the explanations, you guys can check out the explanations towards the end. But please pause the video, grab a piece of paper right now. Let me just go say the problems. Number 1, 6r plus 42. Number 2, 10b squared minus 4b. So these are b's, apologies. I don't think I'm going to use b's again because they look like 6's. Number 3, x squared plus 15x plus 56. Number 4, 4n squared minus 56n plus 196. Number 5, 2x squared minus 72. Number 6, 7p cubed minus 28p squared minus 980p. Number 7, 3b squared minus 25b plus 50. So sorry, yeah, these are b's. They kind of look like 6's in my handwriting. And then 8x squared plus 73x minus 70. So please pause the video. Do this. Go. Okay. Well, I'm just going to give you the quick answers, okay? So let me just place this over here. All right, number 1, the factored form is 6 times r plus 7. This one over here is going to be 2b, parentheses 5b minus 2. Okay, and then the two factors here is x plus 8, x plus 7. This one over here is going to be 4 times quantity n minus 7 quantity squared. Okay. All right, for number 5, it's going to be 2 times x plus 6 times x minus 6. For number 6, it's going to be 7p on the outside, and then you have p plus 10, p minus 14. For number 7, 3b minus 10, and then b minus 5. And then number 8 is x plus 10, x minus 7. Okay, let me go leave this up, and then if you want to continue on, I can give you a full explanations in just a short bit. Okay, hopefully in the past phases I have been making errors in some of these. You know, I wrote down n's instead of x's. If I do that again, just make sure that you know that these are just variables, okay? But then the numbers should still play out. Let's do number 1 first. You know, your first question always is what's the highest number you can divide 6 and 42 by? And the answer is going to be 6. So we can extract factor is 6, that's your GCF, okay? So that's going to equal to 6, and then after that, inside the parentheses are your leftovers. 42 divided by 6 is 7, and then that's going to be it for that. If you want more, again, this was in phase number 1. Okay. Okay. Just to avoid looking like 6's, I made like these little things over here on top of the b's, like serifs, I guess you call it, for those tech-savvy people. 10b squared minus 4b. Let's go see if we can extract a number first, and we can extract 2. Your 2 is your GCF. Okay, and so let's go extract a 2. I'm aware you can do this in 1 step, but let's just do it in 2 steps just so that you guys are here for the explanations anyway. 10 divided by 2 is going to be 5b squared. minus 4 divided by 2 is 2, and then we still got the b, and we got to put that 2 there. Hence, that's why we have the reverse distribution arrows. Now, also check the variables as well, and we can take out 1b. I am still sick. That's okay. At least you won't get sick through the internet. I hope not. Anyway, that would be weird. We can extract 1b just because there's maximum 1b over here on the last term, and then on this first term over here there's 2. Okay, so for the leftovers, since you extracted 1b, you only have 1b left over, and since you've extracted 1b here, those b's are gone, and so now you're left with 2, and then don't forget the b that you have extracted needs to go on the outside as well. Okay, so this was also in phase 1 on my series. Okay, all right, let's do number 3. Well, there's a 1 in front, and so this started on phase 2. Well, what two numbers multiply to 56 but add up to 15? So if there's a 1 in front of the x squared, we can do it this way. Okay, I can already immediately think of 8 times 7. Does that add up to 15? Yes, it does. And so the answer to this problem is just going to be x plus 8 and x plus 7. That's all we can do in that one. Again, if you want to check, you can check using FOIL or box method, and it will go back to this answer. Okay, so that is 1, 2, and 3. Okay, all right. Let me do number 4 over here. Hopefully I wrote it down correctly. Well, it's too late now because I'm already presenting it. Okay, 4n squared minus 56n plus 196. Is there a GCF? The answer is yes, there is actually for this problem. And for those who have worked it out, the GCF is going to be 4. Okay, anyway, let's do the leftovers first. It's going to be n squared minus 56 divided by 4, I believe is 14n. Okay, and then after that, 196 divided by 4 is going to be 49. Let me just check that just one more time. Okay, 196 divided by 4, 49, yeah. Negative 56 divided by 4, negative 14. Looks good so far. Okay, and then don't forget the 4 over here. Now there's a 1 in front of the n squared, and so, you know, now we can break up that last term. What two numbers multiply to 49 but add up to negative 14? I think of 7 and 7. The only problem is we want negative 14, and so maybe not two positive numbers, but two negative numbers might be better. Okay, so then your answer, your almost answer, is going to be n minus 7 times n minus 7. But if you see two of the same things, this is a perfect square, so you're just going to go n minus 7 quantity squared. Okay, if you want to go back to this one again, this was in phase 3. Okay, let's do number 5. Is there a GCF? And the answer is yes. For those who have guessed it was a 2, it is in fact a 2. Sometimes how can you tell? Well, if they're both even numbers, you could start out with 2. Okay, then you can even think of higher even numbers like maybe 4 or 8. So let's extract that 2. Your left over is going to be x squared minus 36, and then there is a 2 over here. Okay, I'm already spotting that this is differences of squares, and so I'm going to do it this way. You could have also added a 0 x, but let's do differences of squares. Okay, so square root of x squared is equal to x. There's no middle term, but the last term, is that, can you square root it? Yep, it's a 6, and there is a minus sign, and so since this is differences of squares, we are going to follow the pattern of x plus 6, x minus 6, and then don't forget the 2. For those who wanted to do it the other way, so let me just go back to this part over here. For those who want to do it the other way, you could have also added a 0x minus 36. So that is another way to do this as well. Okay, what two numbers multiply to negative 36? 6 and negative 6. This pair works because it also adds up to 0. Okay, so then you have 2x plus 6 and then x minus 6. So you see either method will work out. Okay, differences of squares. This was done in phase 3. Okay. All right, I'm going to go over 3 more problems, and then after that, I think we're good to go with this video. Okay, number 6. Let's go see if we can extract some things, and we can, and I'm going to do that in one step. We can divide all 3 terms by 7. And not only that, we can also take out a p as well. Because this has 3 p's multiplied together, 2 p's, and then there's 1. So we can do this in one step. 7p, 7p, and 7p. Okay, so on the outside is 7p, and then afterwards we have p squared minus 28 divided by 7 is 4, so 4p minus 980 divided by 7. I have on my notes is 140, but then I just want to check that just in case. 980 divided by 7. Yeah, okay, good. Alright, there's a 1 in front, and so we're just going to deal with this last number over here. What two numbers multiply to negative 140? I'm thinking of 10 times negative positive, 1 is negative. You can also have negative 10 times 14, but the one that we're going to pick is this, because we want a negative 4, and they're going to add up to negative 4. So this is going to be 7p, p plus 10, and then p minus 14. This was in phase 2. Okay, 2 more to go. Number 7. Can we take out a GCF? The answer is no. There are no b's. There's no b's over here, and then we can't divide 50 by 3 and 25 by 3. So when we can't do a GCF, then we're gonna follow the rules that we have done in phase 4 and plus phase 5. Okay, so 3b squared, the only way to break this up is 3b and b, because 3 is a prime number. That was in phase 5. What two numbers multiply together to make 50? I can think of 10 times 5, but then if it's two positives make a positive number when multiplied. But if we want a negative number in the middle as our goal, we probably don't want 2 positive numbers. I think we want 2 negative numbers instead. And so for that, let me just show you the correct pairing. The 3b will go with a negative 5. The b will go with a negative 10. Let's go see if that works out nice. 3b times negative 5 is negative 15b, plus b times negative 10 is negative 10b. Yeah, this is a negative 25b that we want. Okay, so that was our goal there. Now we can put it into the 2 parentheses, the 2 factors. Just remember that the first pair goes on the outside, and then the second pair goes on the inside. Okay. If you had also b minus 5, 3b minus 10, that is also okay. Okay, same answer. It's also okay. Alright, we are just getting down to business. Just one more. Let's go. Is there a GCF? No, there's not. And so this is going to be the techniques that we're going to use in phase 6. (8x and x). And remember, there's another way to break up 8x squared. and there's 4x and 2x. And so that's why, you know, these type of problems over here where it's not prime, it makes it just a little bit more difficult because there's a little bit more pairs to work with. Negative 70, we have a negative number, so either one is positive and one is negative. Okay. All right. Let me just show you the correct pairing. I believe the correct pairing, the 8 shall go with the 10 because that's 80, and then the x shall go with the negative 7. Let's try that one out first. And of course, if it does not work, we're going to try out some other pairs. I hope it does work. 80x plus negative 7x, 80 minus 7. Yeah, that is 73x. Okay? Almost done, almost done, almost done. First pair goes on the outside. Whew, what a day. Second pair goes on the inside. Okay, I am planning to do more phases, but I think I am done for now. In terms of more phases, phase 8 and phase 9, I can see myself doing a little bit more Algebra 2 honors kind of stuff. So just check out for those kind of videos a little bit later. Alright, thanks you guys.